Hello, welcome back to my channel, and in this video we are going to learn about linear independence, linear dependence, basis, span, dimensions. These are the 5 things we're going to cover. So imagine you have a vector space such as this. So imagine you have this vector space where you have a set of vector and a set of complex scalars. So what is linear combination? So in my vector space, I have this alpha, beta, and gamma as my vectors, and ABC and all the complex scalars. So if I can write this gamma vector in terms of other vectors like alpha and beta and some linear combination of this is called linear combination of my vectors. I can write a vector by linearly combining all other vectors. And linear dependence and independence comes from the fact that if I can write like this gamma vector as a linear combination of other vectors, so which means if I can write it like that, then it's linearly dependent. And if I cannot write my gamma as a linear combination of other vectors in linearly independent, it's very simple. It's the name says it. So now let me give you an example. So one thing is that, so if I have this 3 vector unit vector I, j, k, which you might have already seen in your calculus classes. So one thing to note that I cannot write my unit vector I in terms of j and k. So this is linearly independent. So all these vectors, and even I can't write j in terms of I and k in terms of I and j. So these 3 vectors are linearly independent from each other. But if I have any vectors in xy plane, but any vector in xy plane is dependent on I and j. So these are dependent vectors. So any vector in xy plane can be written in terms of I and j, which you might have already seen in your previous classes. So this is called linear dependent, and this is an example of linearly independent and linearly dependent. Okay, so now let's study what is known as span. So what if I could find some of the vectors in which I can write all other vectors? This is the idea in your 3 dimension is right. So if I have this unit vector I, j, k, I can write any vector as a combination of these 3 vectors. So we're gonna try to do the same for any kind of vector spaces I have, for which I can write any vector in my vector space as the linear combination of those. And such a collection of set of vectors is said to be span the space, because you can write all the vectors in your space as the linear combination of these set of these vectors. And now let's talk about basis. So we are talking about this a collection of set that can span the whole space, but one of the things we want to make sure is that there is a special name for some for collection of such vector that are linearly independent. So this linear independence, what it makes sure that this is a minimal linearly independence that the span the space, that is called the basis. But if you have just span, there can be some redundant vectors, but you don't want such a thing. So, and also many set can have the same span with different length, but when you have this basis, you have this linearly independent and not many different bases, but there are many different bases exist, but all of them have the same number of vectors. So and the other thing what we wanted to learn about the dimension is just, and dimension is just a number of vectors in any basis. In 3D, you have example of ijk. It has it's a set of 3 vectors, so you're spanning this 3-dimensional space. And in 4D, it would be 4 vectors and all those things. In 2D, you have this x and y, so I and j can span the whole space. And there are 2 vectors, and the dimension is 2. So yeah, so these are kind of the basics of this dependence, linear dependence, and all those things. And yeah, I think that kind of finishes the our discussion on vectors.